Hello everyone, welcome to Cracku DILR series. In this series, we are covering 100 plus CAT level DILR sets for CAT 2026, covering easy, moderate and hard difficulty levels. In this video, you will get one complete DILR set and the PDF will be mentioned in the pinned comment. Download it before you start. Pause the video, try solving the set by your own and continue to watch the video. If you're preparing for CAT 2026 and want a serious DILR practice, then this series is for you. And if you want more DILR sets, we have thousands of them. It's very simple, just go to Google and search Cracku DILR sets.
In this question, it has been given that we are given a n cross n square matrix, and say this is an n cross n square matrix. It is given that no two adjacent cells have the same numeral. So, and the definition of adjacent is given that these two cells are obviously adjacent, these two cells are also adjacent, but there is also diagonal which is considered as adjacent. So, this number, if this number is say 1, this number can't be 1, this number can't be 1 and this number can't be 1. It is said that a cell in one corner has 3 cells adjacent to it, that is these cells, and a cell in the first or last row or column which is not in the corner has 5 cells adjacent to it. So for example, this cell has 1, 2, 3, 4 and 5 cells adjacent to it. Any other cell has 8 cells adjacent to it. So for example, any cell like this say has 1, 2, 3, 4, 5, 6, 7 and 8. These are the 8 cells adjacent to it. This is the information that is given in the question. Now let us try to solve the questions. What is the minimum number of different numerals needed to fill a 3 cross 3 square matrix? Let us first quickly draw a 3 cross 3 square matrix and then try to fill with the least possible number of different numerals. So this is a 3 cross 3 matrix. Now if you are assuming that the number in the left corner is 1, surely the numbers which are adjacent to it have to be different. So this will be say 2, this will be say 3 and this will be say 4. Now remember that all of them are adjacent to each other. Now if these three are, if we have already used 4 numbers, let us try to use the same numbers to fill up all the numbers in the matrix. So if this is 1, this number can be 1 because this is not adjacent. So let us first use as many 1s as we can and then we will use as many 2s as we can, 3 and 4, and if it doesn't fit then we will see what to do then. So this can be 1 because this is not a neighbor and this can be 1. Now let us try to use 2. If this is 2, this number can't be 2 but this number can be 2. So we will put 2 here. Now this number can't be 1, this number can't be 2, this number can't be 3 but it can be 4 because 4 is not its neighbor. So using these 4 numbers we have managed to fill up the entire matrix, 3 cross 3 matrix. So the required answer is 4. Now let us do the next one. What is the minimum number of different numerals needed to fill a 5 cross 5 matrix? We'll do the same one. Let us first fill out a few numbers, then try to see if we can fill out the remaining without using any more numbers. If we are not able to do it, then we will use numbers as and when we need them. Let us first draw the 5 cross 5 matrix. 1, 2, 3, 4. 1, 2, 3, 4. So again let us fill this up by 1, 2, 3 and 4. These are the numbers that we have already filled up. Now let us try to fill 1 in as many places as we can such that it is not adjacent to each other. This number can be 1, 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 this is 1, this is 1 and this is 1. Notice that none of the cells which have 1 in them are adjacent to each other. Now let us try to use 2 in as many places as we can. This number can be 2, this number can be 2, this number can be 2, this number can be 2 and this number can be 2. Now we will do the same for 3 because this is 3, this can't be 3 but this can be 3. Similarly this can be 3 and this can be 3. Now we will fill the matrix with 4. This can be 4 because 4 and 4 are not adjacent to each other. This can be 4, this can be 4, this can be 4 and this can be 4. So using these 4 numbers 1, 2, 3, 4 we have managed to fill the entire matrix with different numerals. So the required number of minimum number of numerals needed is 4. Now let us go to the next question. In this question it has been given that suppose you are allowed to make one mistake. That is, one pair of adjacent cells can have the same numeral. what is the minimum number of different numerals required to fill a 5 cross 5 matrix. Now here you should understand that earlier in the earlier question we were able to fill a 5 cross 5 matrix using 4 different numerals. Now here they are giving us some sort of a leeway. They are saying you can commit one mistake. Now will you be able to use lesser number of numerals? Now if you look at the options, you will see that the smallest number is 4. And the way the question is phrased is, you know that the answer has to be either 4 or less than 4. Because 4 is the smallest number here, you can automatically tick it. Now this is the fastest way of solving it. If you actually want to solve it, we can fill up the 5 cross 5 matrix as we have done before, like in the earlier question. We'll just go to that one for ease. This is how we filled up the earlier table. Now you can make one mistake. So you can remove this number, say this number, and replace it with 3. Here you are committing one mistake where these two cells are adjacent to each other. But still overall in the 25 5 cross 5 matrix, in the 25 cells, you will have to use a total of 4 numbers. Yes, you are using lesser number of 2s and more number of 3s, but overall you will be using 4 numerals. So there is no way in which you can fill up this matrix with just 3 numerals. Now let us go to the next question. Suppose that all the cells adjacent to a particular cell must have different numerals. What is the minimum number of different numerals needed to fill this 5 cross 5 square matrix? Here there is a slight difference from the rules that were given initially. Initially there can be a cell, but its value will not be the same as the cells adjacent to it. But now what he is saying is the values of all the cells which are adjacent to a particular cell have to be different. So if you actually draw it, if you look at the earlier one, for example, 2 here is adjacent to 2 ones. Now that is not possible. All the cells which are adjacent to 2 should have different numerals. So let us again first draw the 5 cross 5 matrix and try to fill it up with as few numbers as possible. 1, 2, 3 and 4. 1, 2, 3 and 4. Here what I'll do is I'll first fill up the one in the center because I need different numbers. So this I know that all the numbers which are adjacent to it should be different. So I'll fill it up with 2, 3, 4, 5, 6, 7, 8 and 9. So I need at least 9 numbers for sure. Now let me try to fill this up with 9 numbers. If I'm able to do it, then it is good. If I'm not able to do it, I'll keep adding numbers as and when I need them. Now if I'm filling these 2, 3, 4, these cells are not adjacent to the cells above it. So I'll fill this up with 2, 3, 4. Also note that the number 8 and 2 are separated. The numbers 2 and 8 here are separated. That is the reason I have put 2 here. Similarly, 7 and 3 are separated, so I put 3 here. Similarly, 6 and 4 are separated, so I put 4 here. So I'll do the same thing where all the numbers I'll keep repeating them when they are 3 cells different from each other. So for example, 8 is here, so I'll put 8 here. Similarly, 7 is here, I'll put 7 here. Similarly, 6 is here, I'll put 6 here. Even for these 3, I'll put numbers which are 3 columns to the left. That is, this will be 8, this will be 2, this will be 9. And this number will be again 8 and this number will be 2. These two numbers will be 3 away from the right column. So this will be 6, this will be 4. This will be 5, that is this number. This will be 4, that is this number. And this is 6. Now, so using 9 numbers, we have been able to fill up the matrix 5 cross 5. There are multiple ways in which you can use 9 numbers to fill this up. I have just put on one such permutation. Now, but what we have proved is we need at least 9 numbers and we can do it with 9 numbers. So the answer is 9.
To crack CAT with confidence, you need a lot of practice and a lot of testing. And the questions that matter the most are the questions that have come in CAT previous year's paper. Each of these CAT previous year's paper you can attempt on Cracku. You can download it as a PDF or you can actually take it in the mock format. Not only that, but each of these questions has a detailed written solution as well as a video solution. You can take these in the mock format and later you can analyze your strengths and weaknesses. You can pinpoint the areas you need to improve in. So see how real CAT questions are asked. Learn from the detailed solutions. So build speed, accuracy and confidence. So visit Cracku today and start solving our previous year's CAT papers.